Good evening, students. Once again, welcome back to Chemistry Bridge classes. So, in yesterday's class, uh, I have completed about how we are going to go for like checking of the acids and bases. That is there, is it going to be how much strong and weak? Then later, just after that, one of the reaction, that is when acid is treated with base, then it is that reaction, it is going to be called neutralization reaction. So then finally, just after concluding that, that is I have started with starting with your common salt, that is resulted by the reaction between, that is your sodium hydroxide, a base, and acid, hydrochloric acid. So it will give sodium chloride, sodium chloride. So this sodium chloride, it has got various like applications. Everyone knows this common salt, that is which we are using for means in our whatever daily foods, that is like food preparation. So along with that, it has got some other application. Out of that, yesterday we had a discussion, that is like I have said, uh, this compound, that is it is going to find useful, it is going to be useful, that is for the preparation of one of the chemical compound that we are going to call it is sodium hydroxide, sodium hydroxide. Now even in yesterday's class I have given how this sodium chloride, sorry, using sodium hydroxide we are going to produce, that is, or we are going to prepare this your sodium hydroxide. So just you take this your sodium chloride solution, that we are going to call it as a brine solution. That is, when you subject it for electrolysis, then what will happen, we are going to get this your sodium hydroxide, and uh, that is other byproduct, is going to be hydrogen and chlorine will be liberated. And as during this process we are going to get this your base sodium hydroxide, which is alkali, and that is like byproduct will be chlorine. That's what is going to be called chlor-alkali process, chlor-alkali process. And it is that is aqueous solution of sodium chloride, only we are going to call it is brine solution. Then later, just we had a discussion what applications that uses this your sodium chloride has got, sodium hydroxide has got. So that is, the sodium hydroxide has got application in the production of this your soaps and detergents, and it is going to be used in paper industry. And along with that, that is this sodium hydroxide is useful, one of the what you can say reagent in the chemistry laboratory. Now, along with that is during this process, that is preparation of your that is sodium hydroxide by electrolysis of this your brine, we are going to get another two compound, this your hydrogen and chlorine, hydrogen and chlorine. So for that also, just I have listed, that is what are the application, that is uses it has got. So this chlorine is used as a like in smaller proportion as a disinfectant, and it is making, that is like when you, because most of the like this were polymers, polyvinyl chloride, so it is obtained by vinyl chloride. To convert that your alkene into vinyl chloride, just we are using this your source for your what you can say chlorine. And these chlorines are used for the preparation of this your that is insecticide, DDT, and this your CFCs. So similar way, this hydrogen finds, which is one of the byproduct in the production of sodium hydroxide by sodium chloride, that is this it is useful in the hydrogenation reaction, that is to convert this your oil into vanaspati and all those things, that is it is called hydrogenation of vegetable oil. And nowadays they are trying this hydrogen, already we are using in some of the like what you can say engine, this hydrogen as a fuel, because it has got high calorific value and it is highly combustible. So they are planning for, that is what you can say, alternate fuel. Now moving to next, uh, uh, along with this your sodium hydroxide, that is they have included in your syllabus one more compound, that is calcium. Chemically, this compound we are going to call it is calcium oxychloride, which has got the formula CaOCl2. Now, this compound we cannot make directly starting from your sodium chloride. So during that is this production of that is sodium hydroxide, we are going to get what you can say chlorine. So by making use of this is what you can say chlorine, and when you react this chlorine with calcium hydroxide, it is called slaked lime, then what will happen, we are going to get this your calcium oxychloride, which is commonly known as bleaching powder. It is commonly known as bleaching powder. So that is starting with sodium chloride, we will get this chlorine. That is already we have just I have shown in the previous slide. So using this chlorine is made to react with your calcium hydroxide. Then what will happen? We are going to get your calcium oxychloride. So this is a chemical name. Generally or commonly it is known as that is like a bleaching powder. Bleaching powder. Now this bleaching powder it has got applications, uses. So mainly this bleaching powder in smaller proportion, that is it is used as a disinfectant. Suppose in what you can say that is water, that is like the water which we are using for your household purpose and drinking purpose, if it contains very small like what you can say or micro that is microbes, so like those they can have some effects to like destroy them. This your bleaching powder, it is going to be added to water to a smaller extent in a dilute solution. So in that sense it is going to act as a disinfectant. And this bleaching powder, it has got application that is mainly in your textile industry as a like cleaning your, that is like removing some of the coloring material and all those things. And even this uh, calcium oxychloride, which is bleaching powder, which has got application in your paper industry, and that is your wood industry, that is like wood industry, it is going to be used as a bleaching agent. Now these are some of the applications of this your what you can say bleaching powder. So along with this, so they have included some other compounds. Other compounds which are going to be obtained, which are going to be prepared, that is from your what you can say sodium chloride, that is like your common salt. So those two compounds are, one is sodium bicarbonate, which is known as baking soda, and another one, it is sodium carbonate, hydrated sodium carbonate, it is called as washing soda. It is called as washing soda. Now how this your first, let me go with here, that is like equation, just how we are going to get this your baking soda, how they are going to be produced or it is going to be obtained. So this using this sodium bicarbonate, just to heat it, just I can write here this equation only, here only, just I can show it, otherwise just I can go with the other this part. This sodium bicarbonate NaHCO3, just to heat it, just to supply energy, then what will happen, it is going to convert into sodium carbonate plus H2O. Now this is the process where just when you heat, that is this sodium hydrogen carbonate, we are going to get this were sodium carbonate. Now the point is how this sodium bicarbonate it is going to be obtained. Now what they will do, this sodium bicarbonate can be obtained by, that is they are going to take once again that reaction of this your ammonia, that is carbon dioxide with brine solution, that is same once again this sodium chloride solution. Then using this you are going to get an intermediate ammonium bicarbonate, NH4 taken twice HCO3. So this compound when they will heat, it will convert into, that is like sodium hydrogen carbonate. So this is, that is like baking soda. So this compound when we will heat, just I have written this equation, so it will undergoes what you can say removal of water and carbon dioxide gas, then we are going to get what this is sodium carbonate, which is we are going to call it is washing soda. So now as all of you are aware, So these two compounds, these are going to be basic, and that is this bicarbonate, that is a washing soda, that is going to be used in your baking process, and it has got application in your what you can say in the production of whatever this your like food items. So generally that is going to be made use. This sodium carbonate, it is going to be like called washing soda. It is in the laboratory, it is used as a base. Along with that, the sodium carbonate has got what you can say it is used for softening even this your what you can say to remove that is what you can say temporary and permanent, some extent to the permanent hardness of your water. So that will have a like in detail discussion, but that is like due to time factor, just I am taking. So using this your common salt, that is your sodium chloride, so we can prepare this like one of the compound, it is sodium hydroxide, this bleaching powder, even this your now I am making it clear here, this bleaching powder we cannot make directly from sodium chloride. During the production of sodium hydroxide by from your sodium chloride, we will get chlorine. So that is made to react with your calcium hydroxide. Then we will get this your calcium oxychloride. But these two, that is washing soda and baking soda, they can be obtained from your what you can say sodium chloride. How this explanation just I have given. So along with some few what you can say applications, that is the uses. What use this your sodium hydroxide is called as caustic soda, calcium oxychloride it is called bleaching powder, that is like sodium bicarbonate we are going to call it as a baking soda, and sodium carbonate we are going to call it as washing soda. They have got the application, now along with this that is even they have included that is whatever this your one more compound, that is we are going to call it is POP, plaster Paris. So that is the last small bit they have been included. What is chemically it is going to be containing. So this your calcium sulfate, it is hemihydrated. Just I am writing here this formula, otherwise I can go to the next space if it is a let me check here. Okay. Okay. This compound, calcium sulfate, that is half water molecule. This compound, we are going to call it is what you can say, that is plaster of Paris, POP. That is, this is plaster of Paris, abbreviated as POP. And this calcium sulfate with two water molecule, it is called gypsum. It is going to be called gypsum. Now, how this your what you can say calcium this your POP and gypsum, they are going to be obtained. Copper sulfate, when you subject it for that is what you can say hydrated calcium sulfate, so then we are going to obtain this your POP as well as this your gypsum. This compound we are going to call it is gypsum. This is small part they have mentioned at the end. Now with this thing I can conclude. So in this particular whatever this topic, under the heading they have included okay this acids, bases and salts. So that is like we have completed, or I have given that information, that is what are acids, then some of the chemical reactions, that is like a similar way for your bases, then how these salts will be resulted by the reaction between your acids and bases, and lastly one of the salt, that is at least common sodium chloride. So how by making use of that we are going to prepare, that is different compounds, that is some nearly 4 to 5 compounds, and what applications they have got. So this is the content just which has been included, and which we have done in previous classes. Now I'll go with the next whatever the remaining time, that is like available time. So I have selected some of the objective type of questions. Probably that is they are going to be asked, or there is like a nature of question they will be asked in your examination, or we are going to get based on this topic, that is acid base and that is salts. Okay. Now, let us consider few questions. That is the first question. That is the first question. First question. The statement of the question is, which of the following, which of the following will turn, that is this, if you have got red litmus paper into blue, red litmus paper into blue. Now already when I was discussing about acids and bases, during that time, just I said, some of the common features, that is the properties of acids, among them, that is like one is they have got what you can just sour taste. During that time, just I said, if the compound is acidic, then when you take a drop of solution, put on blue litmus paper, it will turn to red. And if it is basic, then it is going to be reverse. So based on that one, now here the statement of the question is, which of the following will turn red litmus into blue? That is red to blue they are asking. So if the solution is basic in nature, if the solution is basic, or if the compound is basic in nature, then if you take its solution, just put on that is like what you can say litmus paper, what will happens? The color of that is red litmus paper changes into blue if the solution is basic in nature. Now among the options, just you can see, so definitely the citric acid is acid, carbonic acid is acid, acetic acid is also acid. That remaining, whatever this magnesium hydroxide, which is going to be like a base or basic in nature, because of that reason, that is for this question, the correct answer it is going to be that is A. Correct option it is going to be A, because this magnesium hydroxide solution, which is what we can say basic in nature. So because of that reason, when you put onto red litmus paper, it will turns into blue. Now moving to next question. So the question statement is, which of the following will conduct electricity? Now that is they are saying it is related to, that is conduction of this your electricity, conduction of that is which of the following will conduct electricity. Now during that is like a discussion about the silver acids exclusively, just I have given an information that how this your acids they will produce, because I said one of the general property of this your acids is that is like they will produce when you make their solution in water, or you add acids into water, they will produce H plus ion, and this like ions are responsible for conducting your electricity. So based on that one, now if you see whatever the given option they have given, first if I'll go with this one, that is whatever that given option it is there, like a glucose solution. Glucose being an organic compound, it cannot generate ions into the solution. It will be soluble in water, but it cannot give like ions. So next, that is ethanol solution. It is also similar. That is an organic compound. It cannot. That is what we can say. That is produce your ions. Now this acetic acid being, that is what we can say weak acid, some extent it can, like what we can say dissociate. It can dissociate into that is like H plus, and that is like what we can, sorry, this the extent of dissociation will be less, but it will dissociate into H plus ion, and that is acetate ion. This is called acetate ion. Now remember, that is, it is very important. Like if you are thinking this hydrochloric acid also, it can dissociate and it can form H plus and Cl minus, of course. But they have said here that thing is, this is dry. It's not an aqueous solution, because generally that is once again, that's why I'm repeating, when you take a particular compound, when you add into water to make its aqueous solution, if it is going then only means it will into the solution, it will produce as H plus ion, then it is called acid. Now here this of course HCl it will dissociates, but when you are adding into water or you are making its aqueous solution. But here what they have given, it is dry hydrochloric acid. It is pure hydrochloric acid in the gaseous state. That's why this cannot be the answer. So based on that one, that is this acetic acid, it will dissociate into H plus and CO minus, and this H plus ions are responsible for conducting what you can say that is electricity. Due to that reason, for this question, that is this C option, that is like acetic acid solution, it is going to be correct. Acetic acid solution, it is going to be correct. Moving to next question, that is the statement of the question is, what happens when a solution of an acid is mixed with a solution of a base in a test tube? Now, remember, that is suppose for my convenient, I am taking that is example. Here, what is the statement it is saying? Acid, acid, acid. Now, what they are doing, that is like when a solution of an acid mixed with a solution of base, suppose for my convenient, I am taking acid is this your once again simple example of this your hydrochloric acid, that is like aqueous solution, when you add, that is like when you mix it with what you can say sodium hydroxide, this also it's aqueous solution. Then, as already we had a discussion during this your reaction of acids, this acid with the base, what will happen? This in aqueous solution, this acid will produce H plus, like kind its anion. Bases will produce this your OH minus and its cation. This H plus and OH minus, it will form. It is going to convert into, that is like what you can say H2O. Whereas this one, it is going to form your that is like sodium chloride. So this reaction already I have given. And now remember, this reaction we are going to call it is neutralization reaction. That is neutralization reaction, because this is like number of H plus and OH produced in this reaction, it is going to be same, and that is whatever this resulting solution, it is going to be like neutral. So that's why it is going to be called neutralization reaction. Now, once again, I am reading the statement. What happens when a solution of an acid is mixed with a solution of base in a test tube? So suppose if you are taking this HCl in one test tube and this is your NaOH in the other test tube, you can mix either. So that given options are, just you can see, the temperature of the solution increases. The temperature of the solution, that is here, it is increases, they have given, increases. Is it going to another thing, it is decreases? Then is it going to remain the same? Means like next one, that is salt formation takes place. Definitely. So now this is correct, because when acid and base, it is going to be reacted with that is together, they will form salt. But now in the given options, you can see there is no option like it is only 4. Now generally, whenever you react, that is like acid with base, it will form salt, and during that reaction, that is what will happen, it is going to be accompanied by liberation of heat. Heat will be evolved. So means heat will be evolved means, suppose if you are performing a test tube, just if you are at room temperature, you are mixing, that is like acid and base, just when you touch the base of the test tube, definitely you are going to feel the temperature, it is going to increase. So based on that one, along with this fourth, that is like salt formation takes place, what will happen, the temperature, it is going to increase. So based on that one, for question number 3, that is D is the correct option. For question number 3, D is the correct option that you are supposed to remember. That is because when acid and base, they will react, of course, some of you will be thinking only salt formation takes place. But this reaction between acid and base, it is like an exothermic reaction. The meaning of exothermic reaction is a reaction which is taking place or during that reaction, if heat is evolved, heat is given out, such reactions we are going to call them as exothermic reactions. So based on that one, that is for this question, that is fourth option, that is a D option, it is going to be correct. Moving to next one, question number 4. So the statement of the question, once again, here it is. They have got, this is very, very important. It means, like I'm saying, question, of course, but it is aqueous solution. Now, aqueous solution turns this red litmus to blue. Meaning is, they have got an aqueous solution which turns, that is red litmus paper that is that aqueous solution, it will turns red litmus paper into blue color. Blue color. Now, next, excess addition of which of the following solution would reverse the change? Now, just I can write it here. Suppose in this test 2, I have got some solution. Now, what is the nature of this solution? If I have taken this one, I have added to red litmus paper, it will turns into blue. The meaning of that is, it is this solution is whatever this like in this test tube we have got that solution, it is going to be basic or it is going to be base. Now they are saying this process, how that is like reverse of this one, this blue whatever color litmus paper, how it when it is going to turn, or what you are supposed to do to change that reverse this action. Now here, that is they have given following solution would be added to reverse that your change. Means this solution will turns red to blue. I want to change from blue to red. Then what is the like thing I supposed to do? So here first one they have given by adding baking soda. Baking soda is nothing but this your sodium bicarbonate. Already just we have discussed today only. Sodium bicarbonate solution. Next, lime. That is your calcium hydroxide, which is basic. Next, that is ammonium hydroxide solution. This is the formula, NH4OH. It is also base. Now, hydrochloric acid, HCl. See, this solution is base. So when if the solution will convert into what we can say acid, suppose if it is base, then that red litmus paper convert into blue. Suppose I want to reverse it, that is blue litmus paper I want to convert, blue litmus paper I want to convert into red, then that solution must be acidic. Now already in this test tube that solution is basic. Now suppose if you see this sodium, baking soda, this lime, ammonium hydroxide, all these three are bases. So if you are adding once again to base, already it is basic. Base means that solution will become still basic, but I have to make it into acid. That's why if you add hydrochloric acid, this base is there. After adding some quantity, that base will react and it will convert into salt. But just if you keep on adding some extent, then it will become that solution. When it will becomes when it will becomes acidic, then this blue litmus paper it will turns into red. That's why for question number 4, what is the correct option? That is D is the correct option. By adding that is to the basic solution hydrochloric acid, that is acid, what will happen? That is blue litmus paper, it is going to turn into red. So based on that one, this question 4, it is like correct option will be D. Let us move to that is the next question, that is question number 5. So in this question, the statement of the question is they have given some statements. Out of this statement, that is which is incorrect. That is which is incorrect means it is which is wrong statement, or out of 4 like which are one or maybe more than one. Now that too exclusively that is they have mentioned about it is related to acids. Now under general properties of acids, already I have said these acids will have sour taste. This is a correct statement. It is a correct statement. Now next, they may change the color of the indicator. Definitely. Now next, that is they change the color of blue litmus paper into red. This is also like correct, and this is also that is going to be correct. Now next, the change the color of red. They change the color of red litmus paper to blue. This is not correct, which is incorrect statement, because they are asking about acids. Now this is related to base, because that is like now only previous question. If the solution or if the chemical compound, if it has got basic nature, then it will turns this your red litmus paper into blue. But here they are asking related to acid. That's why this is what we can say incorrect statement. Incorrect statement. So based on that one, for question number 5, that is D is the correct option. D is the correct answer. D is the correct answer. Now moving to next question. Okay. Sixth question. It is not that much difficult. Already, just I mentioned during this discussion of your acids. Now they are saying the acid used in making vinegar. So this vinegar, it is going to be used in the preparation of your food. So like or during that is like some of the food items. So now this vinegar will be used. So this vinegar, it will contains that is what we can say acetic acid. So based on that one, the acid like it is used in making your vinegar, it is going to be definitely, that is very straightforward question, is going to be acetic acid. It is going to be acetic acid. And these two, that is like sulfuric acid and nitric acid, they are going to be your mineral acids. And formic acid is going to be found in your red ants. It is not like what you can say good. So based on that one, question number 6, D is the correct option. Moving to next question, that is question number 7. Question number 7. Now, that is here it is a chemical equation. What is that equation? They have taken here this copper oxide. Now, in this one, this copper is metal. And what is this one? It is oxygen. It is an oxide of metal. So when metallic oxides, when you react with which reagent, that is like X is which is the reagent, so that we are going to get their corresponding what you can say salts, and water will be given out. So now yesterday when we had a discussion about under reactions of this or acids, so just have given information, that is one of the reaction, that is how these like oxides of metal, they will react with what you can say acids and bases. Now remember, that is this is water, it is a byproduct, and this is going to be like copper sulfate, it is going to be salt. So generally, that is this oxides, I said not all the oxides, some of them, that is going to be basic in nature. That's why this X must be your what we can say acid. Even I can say yesterday I have given, that is reactions of acids and bases with your metallic oxides. So under that, just here this reaction we have discussed. So now this metallic oxide, just here example is copper oxide. When you react with acid, of course, now this copper sulfate, it cannot be your like acid, but all these three, that is like hydrochloric acid, sulfuric acid, and nitric acid are the acids. But that is here, that is like you are supposed to check this copper oxide. If I am writing the equation, copper oxide, when you react with sulfuric acid, out of these three acids, when you react with sulfuric acid, it will produce copper sulfate plus H2. Whereas suppose if you are using, that is like same, of course all are acids. If I am using instead of like what you can say sulfuric acid, it is hydrochloric acid, then it is going to produce CuCl, that is plus H2, copper chloride. Suppose if you are using copper oxide, if you are reacting with this nitric acid, it is going to form this your copper CuNO3 taken twice plus H2. Now, but in the question itself, it is given this is going to form copper sulfate. That is possible with your like a sulfuric acid, not with your HCl and NHNO3. Of course, those are also acids. So based on that one, for question number 7, that is C is the correct option. Okay, let us move to another question. When I was discussing about to determine the strength of your acids or bases, so I have given that information. We have got to measure, that is concentration of this your hydrogen ion, H ion. So we have got a scale. So that we are going to call it is pH scale. pH scale. And when I have given that information related to what is that pH and that is range of pH, and that is like how it has been divided into like from what value to next, it is going to be like acidic, basic, and that is like neutral. Neutral. Now, at the same time, just like with one chart just I've given, what are the some of the common what you can say juices are your like present in the body. That is what pH they have got. Now, based on that one, that is the gastric juice, which is the gastric juice which is present in stomach. So, what pH it has got? What pH it has got? This is a question. That is, the question statement is, what is the pH of this your gastric juice which is released during that your digestion, which is present in your stomach. Actually, that is even while discussing about this your pH, importance of pH also, just have said. So whatever the food just will consume, these are polymers. These are polymers. It may be in any form. That is like what you can say your rotis or whatever this your rice and all those things. So these are large molecular mass. They will break down into monomers. That is true for breaking that one. That is like this hydrolysis. It will takes place, and that to undergo hydrolysis, that reaction, whatever even that enzyme it is responsible, that is it should have or it should work slightly acidic pH, not even more acidic pH, slightly acidic pH. That's why that is the pH of this your gastric juice. It must be less than 7. It must be less than 7 because under basic condition it will not work, and if in neutral condition also it is not going to work. So it will require slight acidic. That's why I'm saying slight acidic, not your highly acidic. That you are supposed to remember. Slightly acidic means it is going to be less than 7. So based on that one, for question number this 8, that is that it should be A is the correct option. Now moving to next question number 9. The statement of the question is, which of the following phenomenon they are asking, what will happens when, that is occur when, suppose if you are adding small amount of acid. Now just you are adding small quantity of acid is added to water. Now suppose if you have got, if I am taking an example this is rough like diagram. So here we have got what you can say, this is a beaker. It is filled with, it is containing water. We have got water. Now to this water, what we are doing, that is we are adding to this one, we are adding small quantity of acid. Now that is like they have given, that is it undergoing ionization, neutralization, dilution, or it is going to be salt formation. Now remember, so water if it is that is it is there in this one. Remember that water like we don't know what is like, because here one thing everybody should remember, if the water is distilled pure, then it has got what you can say pH which is exactly 7. Now that is if the pH of water is 7, means if distilled water and the pH is 7, means in which this concentration of H plus is equivalent to concentration of OH minus. That you are supposed to remember. That is like a neutral. Now to this, if I am adding acid, means the meaning of addition of acid, because we know we have taken here water, means the if I am taking example for my convenient, this were added HCl. Already I have got water here in this beaker. Now initially this H plus and OH minus are in the same number if I am considering it is pure water. Now after adding water, what is happening? We know this compound, it is